In this section, we are going to be looking at factoring and figuring out common factors and doing lots of other kind of things. So this is an introduction to factoring. In this section, we don't do a whole lot about it, but the purpose behind why we want to factor something, other than rewriting something, is that factoring is a key tool to help us solve some polynomial equations. And so that's why we learn to factor. And it turns out we do lots of that, and so we want to practice lots about factoring. So we're going to be looking at common factors and describing what factors are. In the last section, we looked at simplifying expressions. So we took something like this, and we used the distributive property, multiply those two, and we came out with another polynomial. And this is a simplified one. And that's what we did lots of in chapter 4. In this section, we want to go backwards. So we want to take something like this and rewrite it as a product. So this is times here, right? A product of two or more factors. That's what we're about in this section and in really the whole chapter. Often when you're doing that, or all the time when you're wanting to do that, one thing you'd like to do is to look for a common factor. And so the greatest common factor, here the definition is the largest term that can evenly divide into all terms, but it's something that we want to, in order to factor something, we're looking for the greatest thing that's in common between the two. So for example, in these two questions, I'm looking for the largest thing that will divide evenly into both those numbers. Again, we're not looking for a denominator. It's the largest number that will divide evenly. Like 12, well, 12 won't go into 16, so I can't use that. How about 6? 6 won't go into 16. 16 has 8, but 8 won't go into 12. 4. 4 is probably the largest number that'll divide evenly into both of those. So for number, 4 would be, and then I'll look at the letters, and for the letters, all you have to do, or the variables, is just pick, I guess, basically the smallest exponent. I guess you want to pick the largest exponent that divides evenly into everything. So in this case here, x squared will divide evenly into x cubed, but x cubed won't go into x squared because you don't have enough x's. So the greatest common factor would be x squared for the letters. So 4x squared would be my greatest common factor for these two. Try this one. Maybe press pause and try that one, come back. Okay, for numbers, there's no number that'll divide evenly into any of those, so I guess I could go with 1. And y's, there's 6, 3, 2. 2 would be the largest that would divide evenly into all of those. So my greatest common factor would be 1y squared or just y squared. Okay, so when we are factoring, we're doing the opposite of what we're doing here. So this question says for to multiply or simplify, so I'd multiply each of those out, I'd get 3x, 3 times 5 is 15. So this expression here is the same as this. It's just that this one is a simplified version. This one is actually a factored version. So in this section, what we're wanting to do is take something like this and factor it. So I want to look for something that's common to both. Looks like this one doesn't have any x's, so I can't take x's out of both. But 3 is a common factor, so I could take 3 out. When I divide this by 3, I get an x. I divide this by 3, I get a positive 5. So this would be a factored version. This is a factor, and this here is a factor. The product of those two give me that. Okay, let's do a bit more, maybe greatest common factor practice, because that's going to help us as we are looking to factor different polynomials. So if I look at these, the largest number will divide evenly into all those, probably 4. Letters, I get M5, M1, M2, M4, so M. m would be the most that I could take out of each one of those. 6 n's, 3 n's, 2 n's, 4 n's. 2 n's would be the largest that I could take out of all of them. So this would be my greatest common factor. For this last one, it looks like 7 will divide into all of those. And then how many x's? Looks like 3. So 3 would be the most x's I could take out of all of those. Okay, so greatest common factor. So when we are rewriting polynomials as a product of factors, I want to look for the greatest common factor in each term, and then divide every term by that greatest common factor, and then you rewrite the polynomial as a product of whatever your greatest common factor is and whatever you get when you divide that into each of the terms. So for example, this one, my greatest common factor, 2 would be my number. For letters, this one only has 1, so it's just going to be x to the first. So look for greatest common factor, done it. Divide each term by the greatest common factor. So if I divide this by 2x, I divide this by 2x, and if I divide this by 2x, in this first one I'm getting x squared. The next one I'm getting 5x, I guess a positive 5x, and the last one I'm getting a 4. Then it says here, rewrite as a product of the greatest common factor. Here's my greatest common factor. So 2x times the quotient when I divide each term by it. So 2x times x squared plus 5x plus 4. If I were to multiply that all out, I should get that original polynomial. Let's try another couple. Okay, I'm looking for greatest common factor. Let me just sort of show you how I would do this, maybe including a middle step that some people forget. Greatest common factor, there's no number, and the y's will be y squared. So then what I'll do is I'll take the y cubed, and I'll take the positive 3y squared, and I'll divide each of those by the greatest common factor, which is y squared. Divide y squared. And like I say, typically you don't write this step in. You just do it in your head, but if it helps you to write it in, that's fine. So y squared into y cubed goes y. Y squared into 3y squared just goes 3. So now if I were to check, if I were to use the distributive property and multiply those, I should get what I started with. Try the next couple here and see what you come up with. Okay, I'll do them. There's no number, so y cubed would be the biggest. If I divide this by y cubed, I get 3y to the 4th minus. Divide this by y cubed, I get negative 5y. Divide this by y cubed, I just get a positive 4. Notice how I skipped that term where I wrote the division of each of those. If you like that though, go ahead and put it in. This one's similar to that one we did on the last page. So 7 goes, and x. That's the greatest factor that'll divide evenly into all of those. If I divide it into here, I'll get 5x cubed. Divide it into here, I'll get negative 7x squared. Divided into here, I'll get positive 2x. Divided into here, I'll get negative 9, no x's. Done. Okay, greatest common factor. Now here's one that's just a little bit extended, I guess, in that here I have two terms, that term and this term, and I'm looking for the greatest common factor. So with the x squared and the 3, there's nothing there, but each of these guys have an x plus 7. So what I could do with this is say, well, x plus 7 is common to both of those. If I divide this one by x plus 7, I'm just left with x squared. If I divide this one by x plus 7, I'm just left with 3. So that's an example of there's a common binomial, that's a greatest common factor. Same game with this one. So here's a term and here's a term. they each have an a minus b that's common, and it'll be my greatest common factor. So I can factor it out front. Because it's a binomial, that's why I put it in brackets. And then, if I get rid of this a minus b out of here, I'm just left with y squared. If I get rid of that out of here, I'm left with negative 7. Okay, so that would be the factored form of that polynomial. Here's another example where you might use that. And it's sort of a contrived question, but I guess it works. When they say factor by grouping, what they say is, well, let's group these two together and group those two. And what I'm looking for in here is a greatest common factor just between these two terms, not all four of them, just these two. So between these two, it looks like x squared is the greatest common factor. If I take an x squared out of this, I'm left with an x. If I take an x squared out of that, I'm left with a 7. And when I say take out, I'm meaning divide. Okay, that's the first one. Now this next one, there's no x's common, but a 4 is common to both. So I can take out a positive 4. If I divide this by 4, I'm left with an x. Divide this by 4, I'm left with a 7. Now I have two terms, that term and this term. They each have an x plus 7 in them. If they do, if that is exactly the same, if it's common, I can factor it out, and then I'll be left with x squared plus 4. That's called factoring by grouping. If you want to maybe try this one, go ahead and press pause and then play to see if it works. Okay, I'm grouping these two and these two. Common factor, there's got to be a 2 and an x squared. If I take that out of here, I'm left with a 4x. If I take a 2x squared out of that, oh, I have a 2x squared. I guess I'm dividing. If I divide something by itself, I'm left with a 1. Okay, out of these I can take a 3, a positive 3, and I'm left with 4x, and 3 divided 3 is another positive 1. Again, here's one term, here's another term. They each have a 4x plus 1, so I could factor that out because it's common. And then with this one, if I get rid of this, I'm left with 2x squared. With this one, I get rid of this, I'm left with plus 3. Okay, so that's an example of factoring by grouping. So you'd first do a greatest common factor with each group, and then see if there's a common factor after that. Okay, so that is a quick introduction to factoring out a greatest common factor. Turns out that every time you factor something, that's the first thing that you want to try. All right, there's our introduction to factoring.